And the second idea is that death serves a purpose is also wrong, because what serves a purpose is not death, but is the resources that are freed, renouncing immortality. So it's not that death is useful, it's that immortality is useless.
André Klarsfeld is a professor of physiology and the author of a number of books, including the one that interests us most, The Biology of Death, The Origin of Mortality. It asks why most living creatures are doomed to die naturally, even when they have a favorable and secure environment. Is death as a biological process useful, or does it correspond to any natural necessity? It also asks, why do we die? Do all living creatures share this fate? Is the body's slow degradation with the passing of time unavoidable, or can the secrets of longevity be unlocked? I apologize for disappearing partway into this episode. This was due to losing my connection as the result of a power outage, but Olivier carries on splendidly without me. Please support the show by liking and sharing this episode on social media, and to make sure you don't miss out on any future episodes, please sign up for our newsletter at deathhangout.com or by clicking on the button on screen. Now, this episode, The Origin of Death.
The subtitle of the book is The Origin of Mortality. So the biology of death or the origin of mortality. And that's very intriguing because it's something that we don't ask ourselves. We basically say, well, we live, we die, that's it. But why? Why do we die? Obviously, we can be eaten by a shark or, I don't know, that's this kind of accident. When we get old and suddenly we die, what is the process? Why do we have to die?
As you very well said, the idea that mortality can have an origin is not trivial in itself. In fact, one of the most pregnant, perhaps, human experience is that people die, and nobody has ever been seen not to die. So it seems like an inescapable fact of life that it should end one day with death. The very idea that you can imagine a world where death does not exist may seem a fancy idea, but in fact it's not. That was underlined first by August Weismann, who was a great German scientist of the late 19th, beginning of the 20th century. And he asked himself this question: why, in fact, since life is so powerful that it can make a whole organism out of a single cell, and then maintain that organism for many years, in fact centuries in certain cases, why is life incapable of illimited persistence? He reasoned that, in principle, you can imagine a form of life that would not know any natural death, so that it would be able to renew itself or repair itself perpetually. So he takes that as a thought experiment and asks, how would that organism fare in actual life, in the actual world as it is? He remarks that however good the repair mechanisms of this organism are supposed to be, he or she or it cannot avoid all risks of accident, as you mentioned, natural catastrophes, floods or earthquakes, or you name it, predators, of course, disease, which is in a sense a form of predation by microbes. And so eventually all the efforts that this organism will have invested in staying alive, staying young, eternally young, will come to nothing, will be wasted. That sets the stage, if you want. That's really the main idea, is that to preserve the organism eternally, you have to invest a lot of energy and resources, and these eventually will be wasted because the organism will die anyway. So if you set this in the context of natural selection, August Weismann, he's famous in part for being a very staunch defender of Darwin's ideas on natural selection. He considers this thought experiment in the context of natural selection, evolution by natural selection, Darwinism, if you want. And so he says, what happens if an organism relinquishes part of the effort that he puts into staying young forever, so repairing itself? What if, instead of that, he divests part of this energy into making more descendants, into having into reproducing more efficiently? I think we've lost.
I think we lost Keith. Just give me 1 second.
Weismann's great insight was that the resources invested in maintaining the organism perpetually young could be better used in reproduction. And that's the only currency that natural selection will care about, not how long an individual will last, but how many descendants he will leave behind. That was subsumed in what is called Leonard Cole's paradox in the 1950s. So it took fully half a century or more to actually get these ideas into the mainstream. So Leonard Cole imagined an organism, a species, with two different strains, which differ genetically, and one is genetically programmed to be able to last it eternally, not to know any natural death. And the other one, the other version of that organism, is genetically programmed to die after one bout of reproduction. Let's say it reproduces every year. So every year, this organism leaves a certain number of descendants, and then itself dies, and then its descendants reproduce, etc. Of course, the latter version, the second version, seems very unfavorable intuitively, because it dies after just 1 year, whereas the other one is endowed with potentially mortality. So the question is, which genome, which set of genes will be favored by natural selection, and that means which set of genes will be more represented in the next generation. If you start with an equal number, for instance, of the two genotypes, of the two strains of organisms, the immortal one and the mortal one. And you can easily see, without great computation, that in the immortal strain, the population after 1 year will be the number of descendants left by the organisms plus the surviving parent. Yeah. In the other case, the number of descendants will be just the number of the size of the population would just be the number of descendants, since the parent, by hypothesis, died after giving birth. And so the difference between the size of the two populations is just one, is just the parent. If you reason just for simplicity's sake, we reason just you take one organism of one kind and one organism of the other, but the immortal organism will be less represented in the next generation, the following year, if the mortal one has reproduced by at least 1 unit more than the immortal one, because that's the difference, 1 unit, the parent. The number of mortal organisms will quickly overtake the number of immortal organisms, provided, that's the conclusion, provided that the mortal organism reproduces by 1 unit, at least strictly 1 unit more, the immortal one. So that's Cole's paradox, and it shows you how, in a nutshell, you have the image of why investing resources in immortality necessarily loses in the competition with organisms that forego immortality and have more resources to invest into reproduction. I hope this is clear.
No, it's pretty clear, but it's too bad for us, though, because we die. At the end of the day, it reminds me of what Richard Dawkins and his book, The Selfish Gene. We are just the carrier, us, of genes. Us as an individual, we don't matter that much. for nature or the natural selection, our duty is only to pass on this gene. So is it the idea that we just described? We're just this carrier without any other use?
That's the idea. You're not, I mean, there's a sort of anthropocentrism in talking about selfish genes, attributing qualities, and this is what made Dawkins so powerful, of course, because it struck people. But in fact, you can find it already in Weismann's writings at the end of the 19th century, so almost a century before Dawkins wrote. One of Weismann's theoretical inputs into biology was to distinguish between the somatic line and the germ line. The germ line are the basically the cells of reproduction, so spermatozoa and oocytes for humans, for instance, or for mammals in general. And so this germ line, in fact, you can trace the genealogy through the germ line cells that goes immemorially back to the first living cell, actually. If we are here today, it's because we descend from the first living cell. Weismann says that this germline is immortal. Okay? The cells have not ceased reproducing, and in his time, he didn't talk about genes, because genes were invented a decade or more later. So he wouldn't talk about genes, but he would say that, so he wouldn't say that genes are immortal. What we could say today is that the gene is passed on from generation to generation, is copied more or less faithfully, so it evolves. Yeah. It's not the same, it changes, but there is a completely uninterrupted lineage between your gene or my genes and the original DNA molecule, or whatever. Maybe it was not a DNA molecule, but this original reproducing molecule, whatever it was, has found a way to ensure that it was immortal, because we are its descendants today. So Weismann would not have talked about selfish genes, but he talked about the immortal germline, the immortal line of cells that originated in the first living cell.
One thing that is disturbing for us, though, is we consider ourselves as individual with our full power, with potential and creativity, and suddenly we die. We don't exist anymore, right? If you tell any person, well, you know what, your use is only to be a carrier to this very first gene over there, and that's your only role, I believe people won't be very pleased, or they wouldn't see the use of that. They want to do things, they want to create and have this purpose for life. Even for death, they say that there's a purpose in death, and just if we were all immortal, at the end, Earth will be too crowded, and all the resources will be taken and all this kind of stuff. And I believe you mentioned that it's not true in this book. Am I right?
Yes, there are two basic ideas that were held before Weismann, before the modern theories of the modern evolutionary theories of aging. And these two basic ideas were, one, that death was inevitable. That's how things are. And maybe God created death, whatever, but it's here, and we have, there's no choice but dying. And the other idea was that, which is maybe a corollary, which made the first one more palatable, is that death had a purpose. It was inevitable, that's too bad, but on the other hand, it served a purpose which would make things more acceptable. Those two ideas are actually quite wrong. As we saw, that's Weismann's thought experiment, you can imagine a world where aging and natural death do not exist, but then the workings of natural selection will make it happen. Natural death will inevitably creep in. So the first idea is simply wrong. If death is actually inevitable for most natural death, we're talking about natural death. Accidental death is inevitable for anyone. Natural death is perhaps almost negligible for some very few select organisms. It remains debated, but for the general majority, for the large majority, it's just inescapable, not because life means death, but because of the workings of natural selection. And the second idea is that death serves a purpose is also wrong, because what serves a purpose is not death. but it is the resources that are freed renouncing immortality. So it's not that death is useful, it's that immortality is useless. Which is quite different, although in the end it's about the same, but conceptually it's quite different.
So what do you think about all this? Because there's a movement at the moment with Ray Kurzweil, I believe, who try to beat death or find a solution or a cure for death and reach immortality. We talk about the singularity movement, and they believe that with technology and genetic manipulation and all this kind of stuff, we'll be able to repair ourselves constantly and be immortal. So what is your view with this kind of movement that exists today?
So this trade-off, that's a word that's often used by evolutionists as a trade-off between repairing oneself and reproducing oneself. And the more you invest into repairing yourself, the less you can invest in reproducing. Mm-hmm. So there are all kinds of balance are possible. And you can see in nature, some organisms invest so much in reproduction that they die instantly after having reproduced. You can think of insects like ephemeres. So they're ephemeral by nature. The adult form of the insect is born just to reproduce, and then after the female have laid eggs, they die, and the males die as well. Or salmons, which go up the river where they were born, and that's a great effort. So they arrive almost completely exhausted, just in time to lay eggs, to reproduce and lay eggs. Then they die because they have invested so much effort into reproducing. And at the other end of the spectrum, you have organisms that, such as insects, but the queens of social insects, which do not appear to age. So they eventually die because their reserve of sperm that they got on their nuptial flight, the reserve of sperm eventually is finished. Then they're not so much used to the nest, and the workers actually dispose of the queen. But it seems that the queen, as long as it produces, as it is fertile and produces eggs, will live on without any aging. Mm. Of course, it's not a very funny life because it sits immobile, doing nothing but laying eggs. But still, it shows that if you have this possibility of laying eggs in a well-protected environment, such as a social queen, then nature will have endowed you with whatever it takes to live on without aging. I'm not sure where I was going to now.
So the question is, we know that some organisms can potentially be immortal. So is it possible for us one day to do exactly the same, like repair ourselves constantly?
Maybe you can achieve something like the fate of social insect queens and just become a potato couch and do nothing for the rest of your life, which is not very exciting, I find. More seriously, the biology of humans, of all organisms, has a long evolutionary history. So our genes are a reflection of that history, and there is a rather delicate balance between, again, grossly speaking, whatever energy and resources are used for maintenance or repair, and the energy that is used for production. This equilibrium, this fine balance, I believe that it's very difficult to disrupt it in predictable ways and in efficient ways. That means that I would bet that if you, for instance, delay some manifestation of aging, that means that you force, in a sense, the organism to invest more in repair. That will translate into loss of fertility or greater problems in reproduction, or maybe some other problems that we are unable to anticipate. Because this is such a delicate balance, and actually it's quite a miracle that, if you think of it, that we developed from an egg into whatever complex organism we are. And this balancing act, I think, will be very, very difficult, if not impossible, to alter in significant ways. I strongly believe that, of course, we can, and we have already improved aging. I mean, you can replace a hip not to mention a heart. Maybe a mechanical heart will be available, which is not really the case now, but it doesn't take too much extrapolation to believe that it will become almost as trivial as changing a hip is nowadays. That doesn't mean that you will not age, that the rest of the organism will not age. And even if you could replace every organic part with a mechanical part, if you can imagine such a thing, which is quite difficult to imagine in the near future, what would you do with your experience as a human being, as a flesh and bone human being? How would that be compatible? How would your brain react? In fact, it's already clear that the brain cannot handle such things as virtual reality. Right. If you lose contact with reality, then you can lose your balance when you get out of a virtual world. People have a lot of problems. It's just that the human brain is a miracle, but it has also its limitations, which stem from its evolutionary history. And I don't believe that you can change this anytime soon.
What can we tell people, actually? Because if we know that the choice has been made for us a long time ago, and the choice is to reproduce ourselves, and that the entire energy is about reproduction. The energy has been invested on reproduction, and that's why at the end, I guess we're getting old and die. I think there's this senescence also process behind that. Is there any comfort or anything that we can tell people, any comfort thoughts for everyone, knowing that death is there at the end of the day?
Science as such has anything to bring in respect of comfort. I think science just asks questions about how the world is, and the answers are fascinating in themselves. Yeah. The fact that we can understand that world with our limited brain. And it may mean, actually, that's a philosophical question that is currently asked. Since the human brain is the product of an evolution, oops, that's my telephone. The philosophical question is our brain has an evolutionary history and is a product of a certain environment, and it is extremely adapted to deal with the things that molded it in that evolutionary history. Whether we could understand even things or concepts for which we've never had any experience. Think, for instance, about multidimensional spaces. And we can imagine easily three-dimensional worlds, but it's extremely difficult to imagine a 4, 5, or not to mention n-dimensional worlds, which nevertheless exist conceptually. We just can't form any idea of them. And a few mathematicians probably have some form of grasp of these multidimensional spaces that most people don't have. But so it's easy to imagine that we can't understand everything. And maybe we can't understand our own brain, actually. Maybe the brain is too complex for our brain to understand it. So to come back to your question, I just think that if you are sensitive to how miraculous it is just to be alive, of course, one would want this to last forever. But on the other hand, we can also think how lucky we are, because we could easily not have been at all. You know, if maybe your parents would have split before your birth, and maybe your mother would have had an abortion and would not be here, or maybe another sperm than the one that gave rise to you met the oocyte, and then you would not be you. Of course, it's not easy because we all have problems in our life. Maybe that is already some comfort.
We hope you enjoyed this week's episode. Again, please support the show by signing up at deathhangout.com or clicking on the subscribe button on your screen.